So let us now see the correction in SPD test. As I have told you, there are two corrections. The first one is the overburden pressure correction. The second one is the water table or Dilatancy correction. Now let us see one by one. Now what is overburden pressure correction? See, suppose this is the ground level. Okay, this is the ground level. This is the ground level. Okay, and you have made the hole here, right? And you want to perform the SPD test in these three levels: 1, 2, 3. Okay, this is ground level. Now this is TF1, test 1. This is test 2. And this is test 3. Now what is overburden pressure? The overburden pressure at level 1. Level 1 is how much? Gamma dF1 at 2, gamma dF2 at 3, gamma dF3, right? So you can see that if the depth keeps on increasing, what will happen? The overburden pressure will also keep on increasing, right? So you can see here at the level 1, see this gamma dF1 less than gamma dF2 less than gamma dF3, right? Because as the depth goes on increasing, the overburden pressure also keeps on increasing. Gamma is the density of the soil. Now, what will happen? The confining pressure is what? K into gamma dF, right? The confining pressure will also keep on increasing along with the depth. Now, what is happening here? As you can see, if here the pressure is less, here the pressure is more, right? So here at the level 1, the pressure is less. At the level 3, the pressure is more. So if the effective level pressure is more, if the overburden pressure is more at the level 3, so what will happen? The number of blows required to penetrate 45 centimeter will be what? Will be more. But at the level 1, the number of blows required to penetrate 45 centimeter will be what? Less, isn't it? See what is happening here. Let me show you here. As the depth increases, the overburden pressure also increases. So at shallow depth, confining pressure will be less. Penetration will be high for few number of blows. The N value will be underestimated here, because what is happening here? At this level 1, the number of blows are what? Less. Here number of blows are what? More at level 3. So here at the level 1, the N value is what? Underestimated. Isn't it? The N value is what? Underestimated. So we have to escalate the N value, right? So what is the formula for that? The formula is this. N1 is equal to what? N naught into 350 by sigma dash plus 70. A sigma dash is what? The effective overburden pressure at the level of the test, right? And this is value up to only 280. Okay, 280. So if the value of sigma dash is 280, 280 plus 70 is how much? 50, 50 or 51 equal to N naught, right? So up to the overburden pressure of 280, this formula is valid. So when the overburden pressure exceeds the 280 value, we don't need to apply this overburden pressure correction, right? Only up to 280, we have to apply this overburden pressure correction, right? Now this is overburden pressure correction. Now next one is what? The water table or dilatancy correction. Now let us see the second correction, that is what? Water table or dilatancy correction. Now what is dilatancy? What is dilatancy? Dilatancy is what? Increase in volume due to shearing. Okay. What is dilatancy? Increase in volume due to shearing. Now what is happening here? In case of saturated fine sand and silt, when the negative water pressure, pore pressure is induced, the modified N value after overburden pressure correction exceeds 15, then it is further modified against the development of negative pore water pressure. As negative pore water pressure increases the effective stress, so the number of blows required to penetrate will be high, overestimated. Okay. Now you can see See, now what is dilatancy first? Dilatancy is what? Increase in volume due to shearing. Now see this diagram. See, this is what on the x-axis we have increase in shear stress, and here on the y-axis we have change in volume. This one is what? For dense soil, and this is for what? Loose soil. See the loose soil. When there is increase in shear stress, what is happening? The volume in the loose soil is decreasing. You can see, but in case of dense sand, what is happening? First, the volume will decrease, then it is what? Increasing. It is what? Increasing, right? Now, what will happen? See this. Increase in volume, what? Decrease in pore water pressure, and decrease in volume will what? Increase in pore water pressure. So, what does it mean? In case of dense soil, okay, which is saturated, right? In case of dense sand, which is saturated, what will happen when there is increase in shear stress? What will happen? First, the volume will decrease, then it will what? Increase. If the volume is increased, what will happen? The pore water pressure will what? Decrease. You can see increase in volume is what? Pore water pressure will be decreased, right? So, what is the effective stress value? What is the effective stress value? It is what? Total stress minus what? Pore water pressure. So total stress, now what will happen? If the pore water pressure decreases in case of dense sand, so what will happen? Negative pore water pressure might induce. So negative becomes what? Positive, right? The effective stress will be what? Now it is increased because the pore water pressure becomes what? Negative. If the effective stress is increased, what will happen? The number of blows required to penetrate for 12 centimeter will be high, will be more. That means what? The n value will be overestimated, right? This overestimated n value needs to be decreased or de-escalated. So what is the formula for that? The formula is this. This is the formula. This n2 is what? 15 plus n1 minus 15 by 2. This n1 is what? The n1 is what? Value after overburden pressure correction. That means what? We will do this water table or dilatancy correction only after the overburden pressure is applied, and if the modified overburden pressure correction value exceeds 15, then only we have to go for what? This water table or dilatancy correction in case of saturated fine sand which is densely packed, right? Now after we have found the modified n value, after we have found this modified n value, what we have to do? Through this modified n value, we can find the friction angle. If one scientist was there, Mr. Peck, he gave this relationship, right? So this modified n value, we can find the uh, friction angle value, right? Through this friction angle value, we can find the NC, NQ, and gamma value. This is what? These are bearing capacity factors, right? Through this NC, NQ, and gamma, we can find the ultimate bearing stress. Ultimate bearing stress is what? CNC plus gamma DF, NQ plus half gamma B and gamma, right? This is what? This is cohesion, right? So this is gamma is what? Density of the soil. DF is what? Depth of the footing, and B is what? Width of the footing. So this is all about the SPT test and the correction made in SPT test. Through this SPT test, we can find the ultimate bearing stress of the soil. Thank you very much.